So we'll take a look at the types of data we're dealing with. And we have population sample data. And we know that a lot of times we work with sample because the population is too big. So the population is all the elements of interest, and the sample is a subset of the population. And so the idea of statistics, basically we are interested in the population. In the population we're interested in is called population parameters. The population parameters are, for example, the population mean and population proportion, percentage, yeah. So we're interested in the average age in the population and the average income, average blood pressure, average weight, and also we are interested in proportions, like percentage of male, females, percentage of people have certain kind of disease conditions. But population is too big, so we use the information from a sample to estimate the population. And to be a good sample, it has to be a random sample. Now, what is a random sample? It has to be representative of the population. So, for example, what about those? If you watch TV, if you visit CNN or Fox News, a lot of times after the political debate, they have the instant survey, yeah, instant survey. So, do you think the instant survey is a random sample? Definitely not. Why? First, people have to have computers to access the website. So what about those people who don't have computers, right? So you exclude those people have without computers. So it's not a random sample. And the second, with a lot of times we're dealing with quantitative data and category data. Category data is also called qualitative data. And the quantitative data, we can perform mathematical operations, like you can add the numbers together, subtract the numbers, and do a multiplication and division. But for the categorical data or qualitative data, you cannot perform mathematical operations. So I will give you some example later on, but for now, let's say a quantitative data is the average income, the income. So my income is $40,000, your income is $30,000. So if I add them together, that's $70,000, and the number is meaningful, right? And for the category data, you receive an A in this class, I receive a B in this class. In this case, it's just for the data is for classification. You belong to a grade A, I belong to grade B. So we cannot perform any mathematical function. We also have cross-sectional data and also time series data. Now, what is time series data? We observe the data changing over time. So, for example, you follow a patient, yeah, and then you follow his weight, his blood pressure, blood sugar level over a certain number of years. So this is called a time series data analysis. And I have one example here. This is the Dow Jones Industrial Average since 2016. So you can see the horizontal axis is the number of years, the time frame, and the vertical axis is the index of Dow Jones. So we can observe the changing of the Dow Jones Industrial Average over time. And hold on. And this is an example of the mutual fund performance. This is cross-section data. We have many different mutual funds. So you can see I have the 5-year return here. Yeah, 5-year return. So this is cross-section, cross-sort, all the different mutual funds. And you compare the performances. Okay. Now, let's take a look at the types of data in detail. And basically, you can see we have quantitative data, it's called numerical data, or qualitative data, it's called a category data. Okay. But within the quantitative data, we have it's called discrete and continuous. Now, what is discrete? Discrete is the numbers that you can use a whole number to count, like the number of students, 5 students, number of cars, 5 cars. But continuous is the numbers can be broken down into finer and finer units, small and very small units. So, for example, if I tell you my weight is 178, but you tell me this is not right, then you give me a scientific scale. Once you give me scientific scale, I find out my weight is 178.921368 pounds. So you can see the number can be broken down into very detailed small units and several digits after decimal place. So that's called continuous data. So again, for the quantitative data, we can have discrete, which you can use a whole number to count. Continuous, you cannot use a whole number to count. For example, the temperature, weight. The temperature can be 32.981. Weight can be 164.9206. And for the qualitative data, we have two. It's called category data. We have two. One is called nominal data. Nominal data is for classification purpose. Like in Hawaii, we have 5 islands: Oahu, Hawaii, a Big Island, Maui, Kauai, and Molokai. But you cannot say which one is better. It's just for classification. And ordinal data is also for classification purpose, but with one more feature, which is an order in the data set. So, for example, the grade for this class A, B, C. So you can see A, B, C are for classification purposes, right? 3 different groups, but A is better than B, B is better than C, C is better than nothing. So in this case, it's not only for classification but also for ordinal. So it's the order of the data set. Okay. So for the nominal data, I have an example here, right? It is not quantity, it's qualitative. It's for classification purpose. Male or female. And what's your hair color? Those are the categories, yeah? And where do you live? So those are the category data. But even, how about your Social Security? Your Social Security has all the numbers, yeah? Your number is 57123456. My number is 508123456. But can you try to add our 2 security numbers together, divided by 2? And of course, you know that's meaningless. We cannot perform mathematical function on the Social Security number. So Social Security number is not a quantitative data. It's a nominal data, just for classification purpose. And ordinal data, not only you can classify the data into different groups, classes, or categories, but also there is an order. So for example, a survey question: how do you feel today? Very happy, unhappy, okay, happy. The first one is very unhappy, all the way to very happy. So you can see the orders, right? And also, how about a class survey? Very satisfied, very unsatisfied, somewhat unsatisfied, neutral, somewhat satisfied, and very satisfied. So again, you can see in this case, there's an order, yeah. So ordinal data is stronger than nominal data because there's not only classification, but there is an order. But be very careful though. We know the order, like for example, A is better than B, B is better than C. This is ordinal data. But we don't know how much better. Why not? Because, for example, the A, let me show you this example. The A could be So you receive a A. Your A could be 99. That's A. And I have a receive a B, and my score is 81. So you see what's the difference between your score and my score? It is almost 18 points. Yeah, 18 points. But unfortunately, in another situation, the A is better A 90. 90. And then my B is a very high B, 89. So now even though your score, your grade is A minus B, but the difference is only 1. So again, in this case, we know A is better than B, but we don't know how much better. So the interval, if we take the interval, you cannot decide the interval between the two categories. The only thing what we know is A is better than B, but how much better, we don't know. We cannot decide. Why? Because this is ordinary data. But so now, if we have quantitative data, the interval data, or ratio data, and then we will have so for example, your test score. Now the interval is meaningful. So your score is 94, my score is 91. We know exactly the interval is 3. Now the difference between interval data and the ratio data is very easy. Interval data, and again, both are quantitative data, so you can perform any mathematical functions. But the interval data, it doesn't have a true 0, so it can be below 0. Right? Temperature can be below 0. But for the ratio data, it has basically it has a 0, absolute 0. So the minimum value is 0. So your test score can be an example of the ratio. Why? Because most of the time the score cannot be below 0, right? Below 0. Okay, so now let's review here the levels of measurement. So I have nominal data, ordinal data. So nominal data is for classification purpose. Ordinal data is everything in nominal data plus the numbers are ordered. Then the ratio interval data is everything in ordinal data and nominal data plus what the proportionate interval between variables. In other words, we can determine the interval between the different levels. And the ratio data is everything in interval data plus one more thing is which is the starting point is absolute 0. Okay, so this is the types of data. So I'm going to stop the video. So hopefully I break down the video into small sections. It will be easy for you to watch.